Good morning. Can you hear me well? Audible? All right. Welcome to the breakout for increasing what we call mainframe adoption, and we tagged it as harnessing the power of AI to modernize and futurize legacy and mainframe platforms. Just to put things in perspective, we will cover a variety of subjects today, ranging from traditionally how we have approached modernizing legacy platforms, both mainframe and traditional distributed legacy platforms, as well as what has AI unlocked for us, particularly in the Microsoft ecosystem. We'll give you some demonstrations along the way. I'm Ravi Khokar. I'm part of Capgemini. I run cloud for financial services in Capgemini, practitioner of many such topics. And honestly, mainframe is everywhere. And I'm joined by my colleague.
Hi, everyone. I'm Vivek Desai. I'm based out of Atlanta. I lead the Microsoft Center of Excellence for Capgemini Financial Services. Great to be on this stage talking to you today.
Thanks, Vivek. There's a mic over here in case you have questions. Towards the end, we'll keep some time for Q&A, and we'll stay back after the session for any more discussions that may be needed. Today, we'll cover mostly what has AI unlocked for us as a concept, and in the lens of how it has accelerated the transformation with legacy platforms. We'll touch both subjects. We'll touch mainframe, we'll touch legacy, and we'll also talk about data, which is the critical part of any transformation. To put things in perspective, if you're using a credit card, chances are that 3/4 of your card transactions today are still being processed on a mainframe. In the health sector, most of your data still resides on a mainframe. If you are taking insurance of any kind, property or health or home, chances are that most of the pricing computations for that carrier is happening on mainframe. The reason I am taking all these examples is because most of our day-to-day use cases, we may think we are leveraging edge and AI and Gen AI at large. Most of them are still happening on a mainframe. But most financial institutions are struggling with skills to support it. Most of the senior members have retired or are on the way to retire. So there's a real gap in our ability to transform legacy platforms, and that's why we felt we should use this session to share some experiences on why and how we have taken AI to significantly accelerate modernization of mainframe platforms. To put things in perspective, most of the industries, financial services is one of them where mainframes are used the most, but you have retail where it's still in use for the most part, particularly for processing mission-critical applications. Next time you trade on any trading platform, and there's a concept of T+1 where it needs to settle, most of the settlement today happens on a mainframe. So very critical workloads today run off that, but most organizations are willing and looking forward to modernize the platforms to cloud. And that's where this session becomes relevant of how do you use Microsoft ecosystem to significantly accelerate the journey. Traditionally, we had multiple choices, the famous 6R Gartner treatment. If you focus on the left part of the screen, we are not just talking about COBOL, CICS, JCLs, but we are also talking about legacy .NET, legacy Java, multiple legacy technologies, for example, Smalltalk, language A and B, and they were written 30, 40, 50 years ago. When I go and talk to clients, what we realize is that the last update on the platform happened 10 years ago, 7 years ago. We are in the era of canary releases. We are in the era of making rollouts every week. And you come across platforms that were modernized 7, 8, 10 years ago. The last touch happened. They were incredibly stable. But if you want to then modernize the entire ecosystem, if a bank wants to create a different experience, they got to do something about the mainframes and the functionality that rides off it. So on the left, we have choices like you rehost a traditional mainframe ecosystem. You take it from IBM tech stack to an x86 tech stack on the hardware level. Then you have choices like you re-platform, where you're very intentional about either emulating the mainframe layer, the Z layer, and there are multiple options available. And these are traditional choices. They are not new. They have been existing for many, many years now. Then in some cases, you retain some functionality, but more commonly, we are now looking at people looking at refactoring most of their mainframe applications. You apply strangler pattern, chip away the functionality, and so on and so forth. And some organizations are bold enough to even make a full rewrite. It takes multiple years. But good news is that with AI, we have now significantly shrunk that rewrite, refactor cycle. And we'll talk about what those avenues are where we have seen most amount of acceleration. So if you take a look at a traditional journey, and I've oversimplified it for the purpose of understanding, there are 5 steps. First, you analyze what you have on the legacy platform. It could even be old Java code. It need not be COBOL and CICS. You need a way to create a digital twin of your legacy platform. And we have invested in technology with Microsoft where you can actually browse your CICS, COBOL interfaces in a functional lens, not just the technology lens, but in a functional lens to be able to create a digital twin of your underlying ecosystem. You can have code base ranging from 10, 15, 20 million lines, and it will create a fully browsable interface for you. I'll show you a demonstration of that very shortly. So that's step 1, analyze what you got. Step 2, which is the hard part, is document it. Traditionally, we have created a lot of wiki pages, Word documents, control flow charts, and so on and so forth. But with AI, now we are taking advantage of natural language. I'll show you a demonstration where we create a digital twin of a mainframe ecosystem and we give you a prompt, just like you use ChatGPT or OpenAI services. You interact with that, and it hides all the complexity behind the underlying complexity of how the code were managed, how they were interconnected, dependencies, control flows. It's all available to you now with the power of AI as a prompt. And that's what we mean by documentation. When we work with many of our clients, we realize that what they think they have as a functionality in their production environment versus what documentation they have, the significant gap. Hence, we introduce the step of gap discovery. Because in most regulated industries, you are expected to disclose what functionality you have on your production systems. And there have been multiple cases where we have gone into senior, very established financial services ecosystems and non-financial ecosystems to realize that there is a significant gap between what people think they have as functionality versus what they really have as functionality running in production. There's a divide. And hence, we automated this step of gap discovery in any modernization cycle. Fourth, migration, we call it migration engineering. My colleague Vivek will give you specific demonstration on all of Microsoft tech stack, where and how it is used. And towards the end, these are mission-critical systems. They need to be validated and verified. You need to be able to compare apples to apples when you roll out functionality, regardless of whether you are replatforming, rehosting, or rewriting. So what are the mechanisms in which AI can help you generate a full test harness, including test data, to be able to compare before and after is something that we have heavily invested as a technology, and Vivek will give you some demonstration of that. So that's kind of the oversimplified life cycle. If you look at the bottom, particular services from Microsoft have played a pivotal role in our ability to streamline this 5-step process. We use Azure OpenAI to be able to analyze with great precision. Then we use Azure Search with AI at the back to be able to give you a natural language prompt mechanism. We use a lot of Copilot ecosystem with GitHub to be able to generate and migrate. We call that migration engineering. And towards the end, we use the enhanced Copilot ecosystem to create test cases, test bed, test data for you. And that's how we have significantly enhanced the cycle. To give an example, when we're working with some carriers, we have seen up to 70 to 80% full automation in the life cycle. So a traditional 200,000 lines of code would earlier take us somewhere between 9 to 12 months. We have now shrunk that to 2.5 months of turnaround into production. That's the acceleration we have been able to create with all the technology at hand. Now, to make things real, let's take some examples. What you see on the screen is part of what we call analysis. This is the tool that we have created in-house, used a lot of AI at the back. Traditionally, a digital twin, you will expect it to give you a browsable interface for a physical infrastructure, number of batch jobs, number of CICS, number of KICS interfaces. We took all that complexity and applied a logical layer on it. So in this example, we're talking about a policy, because that's how the functionality is for a carrier and insurance. And then on the policy, we start drilling down into how many interfaces it has, logical interfaces. And very quickly from that logical interface, we go down into the physical ecosystem, database tables, database attributes, and then blow it out to say, if this is my database table, where else it is being used in the ecosystem? And these are pretty complex interfaces for you to be able to very quickly go down from a physical view to a logical view and get the entire lineage and tracking is phenomenal. Because what that does is it creates a very pointed path for you to modernize the entire life cycle. It doesn't matter whether you're rewriting or replatforming. It gives you a very specific contextual sub-industry view from logical to physical view. This is just one example of how we create a digital twin of your underlying functionality. We have tried this on MIPS ranging from 80,000 to 200,000 MIPS, pretty large, complex estate, and we're able to extract it out and give you a logical view. While this is an insurance example, there are examples like that for banks, for auto insurance, for auto providers like Stellantis and others, where this has been real, our ability to take and analyze and put it back to in a logical interface. Now let's make things a little bit more interesting. We saw that the human capital, the knowledge base for legacy platforms is reducing because nobody is learning COBOL these days in colleges. So we wanted a mechanism using a lot of OpenAI services to be able to start documenting in natural language. What you see on the screen is a fully automated CLI-based version of the tool trying to extract a complicated COBOL page, each segment by segment, and documenting it in natural, simple English. And it does that for millions of lines of code in any single day. The beauty is, initially it was very rudimentary. Then we used a lot of task models that we built with Microsoft to be able to then apply contextual capability, and it can then go across nested interfaces, recursive interfaces, one program calling next, and there is a big chain. We're able to condense all of that, and the logic gives you a paragraph view written in plain, simple English of how the interface is. Now, you can imagine it's hard to have like thousands of these documents with you, even though the tool is converting that for you. How do you converse with it? That's where we go and amplify to the next level, where we give you a prompt. All this knowledge is now made available to you as a simple prompt. For example, in this case, we are asking it, what are my surrender charges? Now, this logic may be across thousands of other implementations deeply into some database stored procedures. The tool and the AI services underneath is able to comprehend that, correlate it, and bring it back to you in a way you can consume. When you use some of these tools, you can then take it, drill it down to the actual field level attribute, COBOL level code base, even Java interfaces. It guides you to a very specific outcome, and it all starts with a simple prompt. That is what AI has done for us in the past 24 months, where it has given us an ability to significantly accelerate the overall modernization cycle. If you take the concept forward, you always also deal with non-traditional mainframe, which is what we call distributed legacy. Very old interfaces for Java, very old interfaces for, let's say, C++. And those systems are also real. They are there today, and they also need to be modernized. We took a note of that, and we created a 4-step process. Vivek, do you want to walk us through?
Sure, yeah, thanks, Ravi. Right, and just before I get into this, right, the important point that Ravi highlighted is, first of all, how do you get a sense of your current state or current estate, right? Which is what the CAP 360 capability that Ravi talked about is very instrumental in creating that current state view for you. The next problem statement that we talked about is, now that you have probably equal amount of documentation as your code, how do you navigate that code, right? And that is where the CAP 360 Copilot enables new developers to get onboarded quickly without them having to read through immense amount of documentation, right? So if I'm a new developer joining a team maintaining some of these complex systems, my learning curve gets reduced significantly because now I have a Copilot Studio chatbot available to me to navigate all of that documentation, right? So this is a capability which did not exist earlier, right? So there were tools out there before which were able to generate dependency views. They were able to perform quality analysis on existing code and so forth, but now taking it forward into generating business rules, I think that is a significant game changer, right? And then further, the ability to query it to, even for example, for a developer to understand like, hey, if I'm using a particular database attribute in DB2, where is this database table being used across my mainframe ecosystem, right? Is it safe to make a change here? Is it going to impact just my one CICS program or multiple programs, right? I think that's a very powerful capability for any developer to have, right? And all of this is powered by Copilot Studio, right? So the key is that we extended the analysis platform and the business rules extraction platform to then transition all of this information into your Git repos so that it is not inconsistent from a developer perspective, right? So there may be a lot of tools out there that can generate information, but it does not lead to a continuity into the developer lifecycle, right? So that is something which we solved for, is how do we create that continuum across the software development lifecycle for you to be able to utilize these outputs from the Cap360 analysis platform and then roll that into your migration engineering process, right? So if you see what we have on the screen, and Ravi rightly highlighted, right, is that when we talk about legacy, we are not just focused on mainframes. Legacy comes in all shapes and forms. So we tend to categorize this as mainframe legacy, distributed legacy, and data legacy, right? And all of these three are important for you to consider to seamlessly migrate the entire feature or entire functionality into the modern architecture. So if you see this process that we have laid out here is once the analysis is performed, as a pre-migration step, you will then zero in on a specific feature or a specific capability, which you can narrow down using the Cap360 Copilot and using all of the assets that were produced earlier, right? The functional specs, the UML diagrams, the business rules in English language. The first step from there is to produce specifications that developers can really act upon, right? Which is your user stories in Gherkin language if you are following a test-driven development or behavior-driven development approach. So that is really the first step, is to be able to process these business rules in natural language and convert them to user stories, right? From there on, how do you take those user stories and generate code in your target technology? It could be .NET Core, it could be Java, it could be something else, right? So being able to target a particular technology using those behavior-driven development feature files or specifications along with the source code, right, in COBOL or any other language, right? So what we have done is essentially created two opportunities or options, right? One is for those who have already adopted GitHub Copilot. There is a path where they can actually create this entire code conversion lifecycle within the GitHub Copilot and VS Code interface itself. And alternatively, there are customers of ours who have preferred to use a bulk conversion approach, right? So we have also helped create a CLI-based interface so that someone can point to a set of COBOL programs, a set of legacy .NET programs, and bulk convert to any of the target technologies that we support, right? So that's where you see the two swim lanes in the second last column, right? Now, along with the code, what is also important is that you establish the parity between what your mainframe or legacy application used to do earlier and what it is doing now after the code conversion, which is where the test engineering aspect comes into play, right? What we have essentially seen is it's immensely difficult for anyone to create retrospectively the test cases to validate the feature parity between the legacy and the modern application. And that's where we have incorporated this aspect into our migration engineering lifecycle is generation of unit test cases, integration test cases, automating them with frameworks like XUnit, JUnit, and so on and so forth, right? And then comes the aspect of data migration and data reconciliation, right? So while we focus a whole lot on COBOL and legacy .NET, et cetera, database is a key element of your migration process, and it's important that we are able to migrate them to modern database, but also then reconcile and validate that none of the records are impacted, your database integrity is maintained in the modern architecture, right? So that's where you see this entire process laid out that accomplishes the entire life cycle of what you would typically do through a traditional refactoring or rewrite approach. We have seen significant lift in terms of time to get to that first output, right, where a modern application and a database gets produced for you with this approach in a matter of few weeks as opposed to several months of effort. And then, of course, the question might be, hey, is this ready for deployment to production? Is this following all of the modern cloud native best practices that we may want to incorporate? So the answer is yes and no, right? So every organization has specific enterprise standards, architecture patterns, and so forth. So while we have over time incorporated many of these architectural patterns and best practices into our migration process and the code conversion routines, there is an element of refinement that you would have to take on eventually to make sure that the code that is getting deployed to production is optimized and meets all of the requirements that you may have from an info security point of view, compliance point of view, and so on, right? But the good part is that all of those manual refinements can be done by your new age developers, right, who are familiar with the frameworks, familiar with the new database technologies, and so on and so forth, right? So if I move forward, what does this look like, right? So I'll probably walk you through what does it look like from a VS Code and GitHub perspective, right? So the first point what you see here is the business rules that Ravi talked about, right, which were very efficiently generated by the CAP 360 analysis platform. Now, what you see here is all of that got added to the GitHub repo, right, for this particular migration program. And now using the same business rules, which are in English language, we are uplifting that to a BDD or behavior development feature file, or a Gherkin script, if you from the open source world, right? And this takes immense amount of prompt refinement for us to create a user story which has all of the acceptance criteria built into it, right? Again, looking back at the COBOL programs as well as the business rules, right? So there's a combination of sources that we are leveraging here to ensure that the BDD scripts or the specifications that are produced are taking into consideration all of the information that you produced in the analysis step, that Ravi talked about, right? So this is the very first step where you are now able to, empower your business analysts to create these, feature files and user specifications without really having to manually interpret what the, business rules are, or manually interpret the COBOL or legacy code, right? Now, from there on, the step of code conversion, right? So this is where, what we have accomplished is created a set of prompt libraries where you can define your own design pattern, right? In some cases, you may want to use a specific ORM like Hibernate and Hibernate and so forth. In some cases, you may want to have a REST API, talking to a certain set of data sources, right? So there are multiple architecture patterns that you would have in your enterprise environment. In some cases, it may be, asynchronous communication or messaging, right, that your mainframe applications or legacy applications may be performing today. So across these different architecture patterns, we have created a prompt library or a prompt book, if you will, that will enable developers to quickly choose their design patterns that they wish to adopt, And then based on those design patterns and the feature files, as well as the original COBOL code, it will generate the modern microservices or REST API code, whether it is in Spring Boot, .NET Core, right, even Azure Functions, right? And all of this is within their familiar VS Code interface, right? So it's not a new tool that a developer needs to learn, and which is really key for developer productivity. Now, we talked about the aspect of test engineering, right? So what you see here is, again, how we are taking the source code as well as the business rules or the feature files and creating the entire test suite to do feature parity testing as well as code quality testing in XUnit, JUnit, or any of your preferred frameworks. So what we are doing is continuously expanding the suite of test frameworks or test tools that we support. But so far, we have at least covered most of the commonly used test frameworks that are typically used in modern development ecosystems, right? So again, as a developer, I do not need to rethink, how I'm going to test all of this code before, I raise a pull request in GitHub. This is something which they get out of the box. Of course, from time to time, they may need refinements in terms of enriching the test data. So, along with the test code itself, what we would provide to them is, based on the feature files and the database schemas, the synthetic test data that they would need to execute these test cases in GitHub Actions pipelines or Azure DevOps pipelines. All of those synthetic test data gets generated for them as well, right? So it is not a manual process for them to imagine what would have been the different combinations of test data that I need to harden this code on, right? So this is really powerful, is that not only now the BAs, we talked about how they are empowered with the business rule extraction, et cetera, then the developers, and then test engineers as a persona, right? How they will again be part of the same AI-driven migration engineering process. Right? Now from here on, what you see is how all of this code that got generated along with the test scenarios, what is important is for developers to be able to package them, containerize them, right, and push all of this into their release pipeline. So again, what you see here is how the DevOps pipelines for Azure DevOps or GitHub Actions, all of those CI/CD pipelines for at least the standard architecture patterns, right? So if you think about any REST API, right, there will be very specific packaging mechanisms for a typical REST API or a microservice, right, or a web application. All of those standard DevOps CI/CD pipelines get generated for them through the same GitHub Copilot ecosystem, right? And all of those integrations into the tooling, come out of the box for them. So essentially, this sort of shrinks the entire life cycle of the initial migration engineering, if I will, from anywhere between 8 to 9 months for a given functionality to 2 to 3 sprints, and from there on, they would of course harden the code further, like I said, and improve the efficiency or refine the design patterns further, right? But what you see here already is significant jump from what they would have done otherwise without the GitHub Copilot tooling or the CAP360 framework that we talked about. Now from here on, let's quickly talk about the aspect of data, right? So there are several database migration tools that you would be familiar with, right? That can migrate DB2 databases or legacy Microsoft SQL databases to Azure SQL, PostgreSQL, et cetera, right? So what we are trying to do is not replicate the tooling that is available out there, right? So we leverage the existing tooling that is available to migrate some of these legacy databases to modern databases. There is an aspect of data transformation, which is where we leverage Azure Data Factory pipelines to perform minimal transformation. Again, the idea is not to create the concept of micro databases for microservices through this approach, but the idea is to really get them, get the developers to a point where instead of working with a vSAM or a DB2 database, they are now at least working with a PostgreSQL or MySQL, right, or Azure SQL database that they are very familiar with, right? And then what we are adding on to these migration tools is the aspect of data reconciliation, right? So the set of verifications that we need to perform is A, of course, the data integrity is maintained, but B also is how do you do this on a continuous basis, so even after you go live, you are able to keep the validation of source and target in the mix, right? So if you are, let's say, doing a beta test in production, you should be able to then ensure that the mainframe data and the modern data is still in sync, right? So overall, what we see is across the application code conversion to test engineering to then database testing as well as database migration, there is a significant uplift that the developers will be able to see across the life cycle. And some of this is very well established in the work that we have done over the last 24 months that Ravi mentioned, right, with some of the large institutions in finance, right, insurance, banking, and so forth. Maybe what we'll do at this stage is ask Ravi to walk us through some of those experiences, right, and see what the learnings were and what kind of results we were able to deliver at these institutions using these approaches we talked about today.
Sure. So we'll talk about two examples. While both of us are from financial services, we have had hundreds of these across other verticals as well. Auto is one where, especially in Europe, where we are seeing a significant adoption of these kind of acceleration into the sector. This particular example on the left side of the screen is a carrier, insurance carrier, and we call this, the closed block ecosystem. Just to put things in perspective, when you buy a life insurance or term insurance or a dental insurance, typically it'll get serviced to you on a real-time basis when the policy, in the duration of the policy life cycle. But then there are multiple other type of policies which are no longer supported. So for example, those of you who bought a term insurance 35, 40, 50 years ago, chances are that that particular type of policy is no longer in existence today by the carrier. And these are called closed block policies. And they are of extreme importance because when somebody phones and says, I want to claim a dental insurance, you don't expect the carrier to say, I can't find a policy. So continuity and accuracy is extreme importance because it is relevant for the brand, it's relevant for how the customers are serviced. So the example on the left side of the screen is 20,000 lines of code, 2 weeks turnaround, start to finish, everything done. That's the summary level information. But if you look under the covers, what we were able to do for this particular client is to be able to take a very complex dental ecosystem, use the tool set, use a lot of GitHub, OpenAI, Azure AI services to be able to significantly extract their information with a pinpoint precision on where the policy rules are. Created a manifest of it, gave a prompt to all the business users, generated the synthetic test data, and then modernized the ecosystem onto a newer platform. It would have taken us, to be honest, in the past 24 months ago, at least 1.5 years to get to processing 20,000 lines of code with that level of accuracy. And this is real because we are in the middle of many such complex journeys where there are policies, millions of them, which are no longer there in the ecosystem because the organization has moved on, new ecosystems have arrived, new systems have been created, but then you just cannot afford to not serve those policies. So in this example, we created a near 100% accuracy in our ability to automate the code identification mechanism, manifest the business rules. There were complexities around. It was done in the US. It's a carrier based in New Jersey. So there are state-specific rules even for dental insurance because that's how the health ecosystem works here. and to be able to understand the nuances and variations of all those policies for embedded in deeply inside these 20,000 lines of code. But at the back, it has an IMS database, which, if those of you who are familiar with IMS, is procedural. And we had to take that to an RDBMS ecosystem that has a fun of its own and life cycle of its own. So the tool that Vivek was talking about for ability to convert data and to be able to create verifications around the data conversion was of big, big help. Same thing done 3 years ago, just the database part would have had a very massive project. There's a team of about 35 engineers, 3 pods that did this program. And that's the type of acceleration which we are now experiencing, which is here and now and real. What we are now also doing is to be able to sectorize this, because there are specific task models that were created to understand a dental ecosystem or a life-term ecosystem into other sectors. And that's how this is evolving to a great extent. On the right side of the screen is also an insurance carrier, and some of which we just picked up 2 insurance case studies today. There are others in banking and other sectors. The right side is pretty complex because this is a commercial lines carrier. Commercial line carriers is people who provide insurance to, let's say, Microsoft or United Airlines and so on and so forth. They were having significant challenges with their billing ecosystem. They wanted to streamline their billing accuracy. They had multiple different systems that were created over the past 25, 30 years, and they wanted to streamline that, rationalize it, and modernize it at the same time. Same size journey, matter of few weeks, we were able to come in, understand, deployed the tool set, created a digital twin. The trick with any billing ecosystem is you can't send wrong invoices to your clients. So accuracy again became the most important step for us to be able to convert and modernize that ecosystem. In this case, our outcome was, somewhere in the range of 76% automation across the life cycle. I mean, there is near real 100% automation for our ability to predict and convert code. But if you spread it across the entire SDLC life cycle, it averaged out to be about 70%. The complex part of any distributed ecosystem is you deal with SaaS, you deal with COTS, and you deal with hybrid. And it's no longer a question of 20,000 lines of COBOL code. You're dealing with multiple different complex integrations. Some of them are REST API, some of them are traditional SOA, and so on and so forth. The tooling was able to predict the test cases, generate that for us. So when we deployed the platform, the test cases and the synthetic data is what made the whole journey possible, because it is able to validate that. You can't run a billing cycle offbeat. You have to wait for a specific quarter to end, and then you run a billing cycle. But for us to emulate that test at the back became very, very critical. And that's where most of the tooling that Vivek is referred to in the testing cycle makes a great deal of difference in our ability to modernize these platforms. So just 2 examples. They've happened in the past 24 months, both of them in the US. Similar examples exist in UK, in APAC, in larger Pan-Asia, where customers have taken a complex journey and compressed it in a matter of 3, 4, 5 months instead of 2, 3, 4 years. Now, if you look at from a CXO perspective, what just happened is we made a business case for mainframe and legacy modernization real. The biggest challenge with any legacy modernization journey was the initial hump that was there to offset that bubble of effort, which resulted into cost, which resulted into a pretty ugly business case, now has significantly normalized. And that has made possible what we now call an accelerated legacy modernization cycle. We've tried that with Microsoft pretty heavily, but we've also used that with other cloud providers. And most matured offering today is with the GitHub surrounding ecosystem and all cohesively integrated with one tool set. We have it available on Marketplace. There is a QR code that will come up on the screen if you want to double-click that, where you can take advantage of the offering. It is pretty cutting edge in our experience because it has not only created a cloud-native endpoint, but also significantly compressed the cycle of our ability to understand with precision what you have in your legacy platform. With that, we are at 5 minutes mark. We would like to open for any questions. Any brave? I can't see this part of the screen. Sure, there's a mic over here if you don't mind stepping in. It's right over here in the center.
Vivek, so the or rather the reverse engineering that you do in order to get the logic, etc., with code that runs into like 30, 40 years back, you will see a pattern in terms of, not a pattern, it's a quite random changes happening all through abends, user abends, and all kinds of stuff. What you don't want to do is end up with, all those changes, right? You want to go straight to the required logic. So what have you actually seen as an output? Rather, does it discern that, these changes have nullified and therefore this is the desired output?
Yeah, absolutely. I think great question, right? So one level of complexity is what you mentioned, right? Is changes over time. Some of them may have been led redundant, right, and not used anymore. So as part of our analysis, right, what we are also able to do is perform activities like orphan code analysis, right? So for example, there are a lot of functions written, there are a lot of programs written which are probably not used anymore, right? How do you identify those programs, right? So when we do the call chain analysis in the mainframe, we are actually able to identify the code that is not used anymore. And we are able to efficiently filter that out and highlight that this is, let's say, a report that was created but not activated for the last 10 years, right? Or this is a DB2 table that has not received any updates in the last 5 years, right? So all of those, aspects of, what you may not want to carry forward into your new architecture or even your new functionality, you are able to actually highlight through the platform, and you can then selectively opt out of that particular functionality or a database table or a stored procedure to say, I would rather not create business rules for it, or I can safely ignore code conversion for these aspects, right? So that's definitely one aspect. The second aspect we run into is the lack of documentation, right? So there's this aspect of inferring how a variable in a particular program resembles a similar variable in a different program, and are they really related or not, right? Or a particular data attribute, how is that related? So I think the power of generative AI or Azure OpenAI is really realized when you can actually go across multiple programs to connect these together and say, hey, this particular data attribute is not used just by this one program, but 5 different programs.
I think some of the embedded information you can retrieve from the system SMF tables as well. So what we do when we run the digital twin is we scan all that ecosystem. So static is one, but then runtime you get a lot of intel from the underlying ecosystem. We have that challenge when you have Autosys and cron jobs on the distributed side because they are not that thoroughly documented. But for mainframe, it's pretty sorted now. Any more questions? There are a few on the online channel which the team has already responded.
I wanted to ask if you prefer like moving the functionality like one-to-one to like reduce the chances for introducing some breaking changes, or if it's better to like understand the business logic and then re-implement it like in a clean way.
Yeah, so I think you have both the options, right? So one is, you can definitely leverage this approach to get to the point where you understand your existing functionality, which is, I would say, half the challenge, right? For the most of the scenarios. You can then take an approach that, hey, I want to stop here and now use this information to take a different approach, let's say a domain-driven design, right? And reimagine my data model, reimagine my APIs and whatnot, right? So that's the path you can take as well, right? That, of course, leads to a longer life cycle of transformation, business case, et cetera, that we talked about, right? And then the other approach is you carry forward into this code conversion approach. You land in a place where now at least you have your data model and code in a language or a format that is easy for your existing developers or the new generation developers to assimilate and then work upon, right? So you have these decisions to take upfront in the journey is, hey, how far you want to go with this AI-enabled code conversion or re-engineering approach, or you take a pause once you have discovered what the functionality is, and then you branch out and pursue a domain-driven design or any other approach.
Thank you.
Sure. We are at time.
We are at time. We're happy to take questions offline, but thank you so much for joining, everyone.
Enjoy Ignite.